Astronomers have spotted what may be Earth's newest quasi-moon, a small asteroid recently cataloged as 2025 PN7. Unlike our familiar moon, this body is not truly captured by Earth's gravity. Instead, it circles the Sun on a path so closely aligned with our own that it appears to accompany our planet, shadowing us in a delicate orbital dance. What makes 2025 PN7 remarkable is how long it may have been traveling with us. Early calculations suggest it has been in this configuration for decades, perhaps quietly keeping pace with Earth for nearly 70 years. At only about 60 feet across, it is small, faint, and easily overlooked, which may explain why it escaped detection until now. But with modern surveys and powerful telescopes, astronomers have finally pulled it from the background, revealing a companion that was there all along. Its presence is temporary. Quasi-moons do not remain forever. Models suggest 2025 PN7 may linger for another 60 years before drifting away, tugged by the subtle forces of the solar system. Yet its discovery is a reminder of how much we still have to learn about Earth's neighborhood. Even after centuries of charting the heavens, new companions can still be hiding in plain sight. A quasi-moon is not a true satellite. It is an asteroid whose orbit around the Sun is nearly synchronized with Earth's. Our planet's gravity pulls it into a strange dance, causing it to appear as if it were circling us, while in truth it remains bound to the Sun. These objects occupy delicate orbital arrangements, looping ahead of Earth or falling behind, tracing patterns that sometimes resemble figure eights in the sky. They are captured, but only loosely. At any time, a nudge from solar tides or a passing planet can release them. Several such companions have been discovered before, each staying with Earth for years or centuries before drifting away again. 2025 PN7 is the newest member of this quiet family, a fragment of rock that has perhaps accompanied us for nearly 70 years. What makes this small world remarkable is not only its presence, but its persistence. Astronomers estimate it may continue this peculiar companionship for another 60 years before wandering off into space. At roughly 19 meters across, it is smaller than the meteor that exploded over Chelyabinsk in 2013, but still large enough to be carefully tracked by telescopes. Yet it escaped notice until now. With a brightness magnitude of about 26, it is astonishingly faint, millions of times dimmer than what the human eye can perceive. Only the most powerful instruments could detect it, and for decades, no one had reason to look in precisely the right place. The discovery was announced in early September 2025, described in research notes of the American Astronomical Society. Though that journal is moderated rather than peer-reviewed, the findings are based on established calculations of orbital dynamics. They suggest that 2025 PN7 has been locked into this quasi-satellite configuration for decades, hidden in plain sight as Earth carried it along its annual path. That invisibility is part of the intrigue. How many more such objects are traveling with us unnoticed? How crowded is the near-Earth environment with these temporary companions? Unlike our moon, which has circled Earth for billions of years, quasi-moons are fleeting visitors. Their orbits are complex, braided paths that are never quite stable. They weave in and out of Earth's gravitational influence, lingering for a while before breaking free. Some, like the quasi-moon 469219 Kamualeva, discovered in 2016, are relatively stable and may remain in Earth's company for centuries. Others, like 2025 PN7, are less secure, vulnerable to the subtle tugs of the solar system. In the coming decades, its orbit will gradually drift until it slips away. But for now, it is part of Earth's retinue, a second moon of sorts, though temporary and fragile. The significance goes beyond curiosity. Each new quasi-moon provides astronomers with a natural experiment in orbital mechanics. By studying these objects, scientists refine their models of how small bodies move under the combined pull of Earth, the Sun, and the other planets. They also learn about the population of near-Earth asteroids, where they come from, how they evolve, and how often they pass close by. Some researchers speculate that quasi-moons could even serve as practical way stations for future exploration, natural platforms that ride alongside Earth and could one day be tapped as stepping stones to the wider solar system.
Yet, caution is warranted. The announcement of 2025 PN7's discovery carries excitement, but it also highlights the limits of what is known. The calculations suggest decades of companionship, but they depend on faint and limited data. Continued observation will be necessary to confirm the orbit with confidence. The fact that the discovery appeared in a non-peer-reviewed form also means the results have not yet been subjected to the full rigor of scientific scrutiny. As with all things in astronomy, more data is needed before speculation becomes certainty. Fortunately, the future promises an abundance of data. The Vera C. Rubin Observatory, now operational in Chile, is expected to revolutionize our understanding of the dynamic sky. Equipped with a wide-field survey telescope, it will scan the heavens night after night, recording millions of faint objects in exquisite detail. Asteroids, comets, and other small bodies will no longer slip past unnoticed. In time, Rubin may reveal dozens more quasi-moons trailing Earth, filling in a census of these overlooked companions. 2025 PN7 may prove to be just one among many, the first of a hidden population. This discovery also connects to a larger history of exploration. The idea that Earth could host temporary moons is not new. In 2006, astronomers confirmed the presence of a quasi-satellite called 2006 RH-120, which stayed with Earth for several years before drifting away. Later, 2016 HO3, now better known as Kamoa-Walewa, was found, a more stable quasi-moon that will remain with us for centuries. These discoveries showed that our planet's gravitational reach is more complex than once imagined. Earth does not travel alone. It carries with it a shifting entourage of rocks, each bound for a time before moving on. Even earlier, astronomers had hints of this complexity. In the 1950s, theoretical work suggested that small objects might be trapped in resonance with Earth, following unusual orbits that mimic a second moon. But the technology to detect such faint bodies did not exist. Only with modern surveys, equipped with digital imaging and fast computing power, has the hidden architecture of Earth's companions begun to come into focus. The discovery of 2025 PN7 is another step in that unfolding story. For scientists, these objects also serve a deeply practical role. Quasi-moons are natural test cases for planetary defense, the effort to identify, track, and understand the countless asteroids that drift near Earth. Each newly discovered body adds another point of reference to refine models of orbital motion. Even a rock as small as 2025 PN7 can help researchers practice the mathematics of prediction, how gravity from Earth, the Moon, the Sun, and even other planets tugs on an asteroid's path, nudging it this way and that. By studying such orbits in detail, astronomers sharpen the same tools that would be needed to predict the future course of a dangerous object. If a larger asteroid ever came too close for comfort, the ability to model its trajectory accurately would be essential. In this sense, even the smallest quasi-moon contributes quietly to Earth's safety. But there is more than mathematics in their discovery. There is also a resonance that touches on the imagination. For millennia, the Moon has been our single, steady companion, a fixture in the sky and a symbol of permanence. To learn that there are other companions, however temporary, unsettles that picture. Quasi-moons remind us that companionship in space can be fleeting, fragile, and hidden. They are partners in passing, companions who slip into our orbit only to drift away again, showing us that the solar system is alive with shifting relationships. Where the Moon embodies constancy, quasi-moons embody impermanence. 2025 PN7's appearance underscores how little we still know about our immediate cosmic neighborhood. Despite centuries of observation, a rock no larger than a house was able to share our orbit for 70 years without being noticed. Its sudden presence in our awareness doesn't mean it's new, it means that only now do we have the instruments to see it. This realization is humbling. If such a body could remain hidden for decades, how many more companions are out there, waiting quietly in the dark? How much of Earth's journey through the cosmos remains uncharted, and how many invisible neighbors travel with us still? In the end, the story of 2025 PN7 is not just about a rock in space. It is about perspective. It shows that Earth is not alone in its orbit, that our planet travels with companions both obvious and hidden. It reveals the gaps in our knowledge and the promise of new discoveries. And it invites us to imagine a sky filled not just with stars and planets, but with unseen partners riding silently beside us. As Earth spins through space, attended by its eternal moon, a smaller shadow follows. Fragile, temporary, but real. A quasi-moon. 2025 PN7, our newest companion in the endless journey around the sun.